So in order to know that two polygons are similar, you need to know that all of the angles are congruent and all of the sides are proportional. Triangles, though, are special. They have special properties that mean we can use some shortcuts. For triangles, we can cut that information down to just knowing that the angles are congruent. If we have three pairs of congruent angles, then we know we have similar triangles. We don't need to measure the sides. This is a special property of triangles. For anything besides a triangle, you still need to test both angles and sides. There's also the side proportionality test. If we have three sides that are all in the same proportion, so they all have the same scale factor, 10 times 2, 5 times 2, 12 times 2 in this example, then we know that the triangles are similar, and so we wouldn't even need to know anything about the angles. We would know their angles are congruent. The third test is a combination of both of those. If we have two pairs of sides that are proportional, and the angle between them is congruent, so two sides and the angle between them, we have proportional or similar triangles. And so let's just test that proportion. I'm going to put 14 and 10, that's my larger side and my smaller side. So I'm going to take the larger side from over here and the smaller side from over here. 14 over 21 reduces to 2 over 3. And 10 over 15 reduces to 2 over 3 as well. So I know I have two pairs of proportional sides and the angles between them are congruent. So we just looked at this example here. We set up the proportion like this, and we wanted to know if those two ratios were equivalent, so do they have the same proportion? If you matched it, if you did 14 over 15 and 10 over 21, you would get an incorrect answer because these two ratios wouldn't be the same. You can test to make sure that you have your ratio set up correctly by testing to see if you have the larger side matched with the larger side and the smaller side matched with the smaller side. So this one, they are similar by side angle side. The sides have a scale factor of 2/3, and the 75-degree angle is congruent to itself, so we can kind of write that out. Angle A is congruent to angle X. So we have the sides in a scale factor of 2/3, and the angles between them are congruent. Now in this example over here, we only are given two angles out of each triangle. So I'm going to go ahead and solve for this third one. This is going to be 40 degrees because 40 plus 100 is 140. 180 minus 140 will give us 40 degrees. 40 plus 40 is 80. 180 minus 80 is 100. So this one here is 100. Once I've solved for the missing angles, I see I have 40, 40, 100, and 40, 40, 100. So these two triangles are similar by angle, 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 because we have both triangles have 40, 40, 100. So we want to test to see if these two triangles are similar. We're given three pairs of sides, so we're looking at side, angle, side. And I'm going to take the smaller triangle and I'm going to start setting up the proportion. I'm going to go from the smallest side to the largest side. And then I'm going to match those up with the smallest to largest from the other triangle. So we have smallest side of 15, 21, and 27. Once I have them set up that way, I can see that each one of these reduces to a scale factor of 1/3. That's the ratio between the two triangles, that's the scale factor. So yes, the triangles are similar. So I can write that out. Triangle ABC is similar. Be careful you're using the similar symbol, not the congruent one. ABC, I want to go in the same order. W, X, Y. said it right and then wrote it wrong. This way, when I write it out, I know that A is going to be congruent to W, B is congruent to X, C is congruent to Y, because I wrote them purposely that way. You have to be careful. I picked this example because it can be kind of tricky when you first start looking at these problems. We have two triangles here. This smaller triangle inside this larger triangle. Sometimes it's helpful to draw them out separately if you're having trouble visualizing. So the sides of the smaller triangle, which I have in this red color here, we have 6 and 4, and this triangle has a side length of 10 and Z. And so I'm going to be solving for the missing side. So I want to set up the proportions so that corresponding sides are together. So I'm going to do 6 over 10 is equal to, so I want 6 to 10, 4 is going over Z. And I can solve this by cross multiplying, which would give us 6Z is equal to 40. Or I can kind of figure out, alright, this reduces down to 3/5. And so I'm going to take this, the scale factor here isn't very helpful because I'm going to be multiplying by 1.33. So let's go ahead and finish up with the cross multiplying. I'm going to divide both sides by 6. 40 divided by 6 is the same thing as 20 over 3, which is going to give us 6 2/3 or 6.66 repeating. Here's another one of those problems where you have a triangle inside of a triangle. Again, here's my smaller one and then the larger one. I'm going to draw them out separately so I can mark off the sides and see the two triangles. And this whole side here is 3x plus 3. So we want to set up corresponding ratios. We've got this time 4 and 6 is equal to 5 over 3x plus 3. Again, I have two options. I can cross multiply, and this is just going to involve doing some distribution. So I'll end up with 4 times 3x plus 3 equals 6 times 5, which is 30. And so then I can distribute. Subtract 12 from both sides. And we're going to get another fraction. 18 divided by 12 is 3 over 2. 3 over 2 is 1.5 in decimals. So that's x, and if I wanted to know what the whole side length was, I would have to plug 1.5 back in for x up here. So I would do 3 times 1.5 plus 3. So I would get 4.5 plus 3, which would be 7.5 altogether. I could also have done this in the opposite order. I could have figured out that the side was 7.5 and then solved for x from there. And the way that I would do that is instead of putting the whole expression in down here, I'm going to just put a question mark. And I'm going to solve for the question mark. So we have 30 is equal to 4 times whatever the side length is. So then I would divide both sides by 4. 30 divided by 4, well, I know that 30 divided by 2 is 15, so 30 divided by 4 must be half of 15. So I know that the side length, yep, there it is 7.7. I'm going to write that over here. So if the side length is 7.7 and the side length is also 3x plus 3, I should be able to set those up into an equation and solve for x from there. And we would get 4.5 equals 3x. And then we would get 1.5 equals x. Either way, I get the same answer. Just depends on which one you feel more comfortable with. So don't forget to write down any questions you have. This was an optional video, so if you have questions, you're going to have to write them up on the chalkboard. I won't see them on your notes. So come ready for questions or stop by before or after class if you feel like you need a little bit more help.